So hello, welcome to the Latent Space. My name's Katie Roberts. I've been hosting on this stage today, and right up next we've got Christopher Batey. He works as a CTO for Core Engineering Consulting Group, and his talk is Building Product Teams in the Age of AI, what we had to relearn every quarter.
Brilliant. Thanks very much, Katie. Yeah. Okay, so what I'm going to go through is kind of everything that we've learned, well, not everything, but certainly the important things for building a product team in the age of AI. So I work for Core Engineering Consulting Group, and there's a key word in there called consulting. And historically, we have been a consulting firm in the domain of platform engineering and continuous delivery. And if I see where we're at about 2 years ago, the majority of the engineers at our organization would be at client sites. And we would only work with like large enterprise clients across media, finance, healthcare, and we'd do two types of things. We'd do advisory, so we'd help them. We'd look at their continuous delivery practices, digital transformation, building developer platforms, and we'd give them advice on how to move forward. And then we'd provide the engineers to go in and help do that thing if needed. They could either take that and do that themselves, or we could go in and help them. And for the people who've worked at this type of knowledge-based consultancy, the way that you operate as a business is because you're specialized in your domain, which in our experience is platform engineering and continuous delivery, you can normally add quite a lot of value because the engineers at our clients, well, they're focusing on media or finance or healthcare. But anyone who's tried to scale an organization like this beyond a handful of engineers knows that it's really, really hard. Because as you get more and more people, it's really hard to keep your edge about being experts in that domain. So you start to build systems for it. And 2 years ago, this is what our systems looked like. So we'd obviously train our engineers internally. And the actual type of training, it would be information on wikis, it would be decks, we'd run workshops, we'd do boot camps with our engineers. The other thing we had was a lot of text and spreadsheet-based knowledge on what good looks like in platform engineering and continuous delivery. So it would be what features does a developer platform have? What type of testing are you doing in your path to production? And we'd have quick ways of evaluating like whether what people were doing based on where they'd want to get to. And then the third was like reference material. So because we kept on building the same type of thing over and over again at our clients, then we'd end up with roadmaps, predefined roadmaps with epics and milestones and tasks for building certain types of things. And that naturally led to reference implementations. So for key features that we kept building and building again for different clients, we'd end up with some kind of reference implementation we could bring in. That is not where we're at today, though. And the premise of this talk is we probably wouldn't be where we're at today without AI. So if I take the training that used to be wikis, decks, and workshops, that right now is an internal interactive training platform. So all the engineers that join our company, they go and learn about continuous delivery and platform engineering. They learn about a concept, say versioning and promotion, or different types of testing, so you can release your software more quickly. And then we have software which provisions them a realistic environment to try that skill out. So training is normally made up of showing something, telling something, but now we have an interactive training platform that can do the thing. So an example would be it automatically provisions them a GitHub repository, an environment like a namespace in Kubernetes, plus say a cloud account, and then the software running in the background, which is checking that they've done the thing, like deployed an immutable version artifact. The processes, which used to be lots of wiki pages and spreadsheets, and all engineers love wiki pages and spreadsheets, is now like an interactive tool which all of our engineers use to track the maturity of various things that we are specialists in at all of our clients. So it could be security, it could be application architecture for continuous delivery, it could be the types of testing or promotion you did. And the reference implementation, so the roadmaps and developer platform features, well, we still use those with enterprise clients, but we use them to build an off-the-shelf developer platform for smaller companies. So rather than just working with huge companies, we now work with small companies where we can install this into their cloud provider, and they can get some of the benefits that the big companies would normally spend millions and millions of pounds building internally. And just to add on some more fun, that internal tool has become a SaaS. So now our actual enterprise clients can log in themselves, and it's reasonably complex to do that. And then the product which we built, which is for small to medium enterprises, well, we're actually its best customer because like when we built it, I wasn't thinking we're going to use this to build all of our products, but now we do, so we use that as a customer. And just to like give you a flavor of what this looks like, well, one of the managed services which we host, this is what I mean by insights. So being able to quickly see the maturity of various stages of a path to production across lots of different components. And then, the developer platform, this is the user interface for it, where I can see which version of which of my components is in different environments as part of the path to production. That's not that interesting, okay? That's just what we build. I think the important thing is we're building two types of systems, right? There's systems which manage very sensitive data. If any of our clients any of the data which we have in the first system that I described would be leaked or exposed in some way, that would probably be the end of our relationship with that client. And then the other product manages people's production environments. So the impact of it going wrong is pretty severe. So that's kind of the impact I want to talk about. I'm talking about building a product team which is going to manage a system where it really matters if it goes wrong, rather than like working on lots of other small projects which might be like websites with basic functionality. And that is in the context of everything we're hearing today in an industry, and especially on social media, that we're rapidly approaching a world where software no human has ever seen reaches production. And I don't think this is hypothetical anymore. And I'm definitely not talking about our side projects or the like one-person businesses where they're quickly ideating and putting something in production. I think that's totally fine. I'm talking about the systems which have your credit card details, or they manage all your personal or healthcare data. And this actually starts to scare me, right? Because code can do anything with the data it has access to. And if we're not looking at that code, it could do anything. So certainly if my bank started doing this, or my healthcare company started doing this, I'd start to be pretty scared. And I think some of the optimism is real, though, right? Everyone who's kind of worked in this area for the last 24 months, especially the last 9 months, the last 12 months, AI has become absolutely fantastic at writing code, right? When we started building these products, it was 50-50 whether the code would compile with these tools. Right now, it's going to compile, it's probably going to work, and I'm more just spending time refining how it works. So it is pretty amazing. That said, I don't think it's so good at other parts of the software delivery lifecycle. So my question for you to think about is writing code the hardest part of software engineering? Because I definitely think that's the best thing right now that AI is good at. And is software engineering really the hardest part of a successful digital product and building products? By which I mean like adopted features in production that potentially generate revenue or whatever impact. And I wanted to I'm sure this isn't going to be the only time you're going to be asked this today, and I've seen this been asked at quite a few conferences up until now, but I wanted to get an idea of who's in the audience. So for the code or digital product that you're working on, that is what you're paid for, I know we've all got like at least 20 side projects we're clodding on at the weekend, so not those. What percentage of your code is currently written by AI? And it's good to exercise, so I'm going to get you to put your hand up. Who here has less than 10% of their code written by AI for their real system? So we got 1, 2. Any like full manual coders? I didn't put 0 as an option. No, so no, but under 10%. What about under 50%? So I'd say maybe 20%. What about 90? Most under 90? 100%. So there's quite a few with 100%. We're there. I would say for us, we're at 90 to 100%. It's very, very rare in my company that any of the engineers actually write some code. I would say, though, that this is a vanity metric, which people like to talk about. Because out of all that code, and if I look in my main branch of any of our products, it's all written by AI now. But how much of it was written without any human intervention, with software engineers like using critical thinking? And I think the answer is probably like 0 for certainly us. I would say that my experience over the last year or so is AI is an amplifier. So for the things that we did really well as a company, it allows us to do it much quicker, right? For the things that we did really badly, which we're trying to improve on, and many of the topic of this talk, then all it's done is amplified the things that we didn't do so well. And for me, it's really enabled like delivery-focused engineers. So people who are really focusing on getting working software adopted in production. It's really like been a game changer for us. And my company certainly wouldn't be in the position it is right now if AI didn't exist, because we couldn't have afforded probably to hire a 10-person like product team 2 years ago. What about this question, which is slightly more controversial? I'm going to see if we get to the same kind of answers. So what percentage of your code goes to production without humans ever seeing it? So the person prompting the agent, the automatic agentic workflow, or maybe someone doing a review after that. So does anyone have no code going to production? Actually, that's more than 50, that's 50-ish%, so I'm pretty happy with that one, actually. Does anyone get all the way to 100% where not a single human sees the code which goes into production? Is anyone at the other extreme? There's a couple. Well, it's good. It gives me hope. We're here. I would love to say actually 0%, even though like we're massively adopting AI and we're massive at my company. I just couldn't guarantee it, so I went with the less than 10%. And I think the thing which like worries me more or more important is what percentage of your code, or really what percentage of your system, goes to production without a human understanding it. And to think about that, I wanted to like dig into and start to think about what we actually do to build a digital product. So we've produced code for a long time, digital assets, and we end up with a product. And the producer has, up until recently, been a human, flesh and blood. Product owners, QAs, developers, it was a team. And the thing we produce is a digital asset, right? It's code, it's an artifact, it's verification, it could be the testing, it could be the monitoring and alerting, it could be the documentation. So this is where we were at a couple of years ago. Now, the production of our digital product is very much becoming a black box to all of us, right? So you could be using some agentic workflow, you could be using Claude Code, some kind of autonomous agents, but I'm not too worried about this, right? Because I'm still producing my digital product, which I own at the end of it, and I understand it. But of course, it's a slippery slope which we're all being pushed into doing. Go faster, go faster, go faster. So at some point it becomes this, where we don't understand really how it's being produced, and we don't actually understand the thing that's being produced. But don't worry, because obviously the answer to this is we look at the verification, right? So as long as you understand the black box tests of the thing you now no longer understand, it's okay, right? If I understand, say, my acceptance tests, my functional tests, it's doing the right thing, then everything's okay. But when people do this, what I find is it quickly becomes this, then quickly becomes this, then quickly becomes this. And then no one understands a thing with what's going on. So my first tip, and the thing which we've tried to work on recently inside my organization, is to not delegate our systems thinking to agents. So I'm not going as far to say as everyone understands every single line of code, but let's not delegate systems thinking to agents. So I want to give you a concrete example of a change in our delivery process that we made recently. So here's a very simplistic architecture diagram of one of our managed services. We've got private backends like training, Pulse, Insights, Teams. We've got a public front end and some kind of authentication service. What it does doesn't really matter. But this is something our clients just log into, right? They have no idea how it's implemented, and if they ever knew how it was implemented, it was probably because we broke it somehow. On the other side is something we deploy actually at our clients. And this is an intentional system design because it has access to their data, and it does lots of processing where the clients would not want that data to leave their premise, their network. So it has its own front end. Now, lots and lots of features keep on getting requested that require this connection, right? Some of the functionality we've got in the managed service, and then combining it somehow with the client-side agent, which is running and collecting and processing data. Now, I could just describe the feature I want, right? The feature I want which would combine this. And I'm pretty confident that our agentic workflow would build it. And then maybe a pull request is going to land, which is maybe 7,000 changes. And then what would I be reviewing it for? Well, I'd first want to be reviewing it for the systems thinking. So here's some questions which I just threw together about what I'd want to know about this change. How does the client side connect to the managed? What does it connect to? How does it authenticate and authorize? Because this is a client side component talking to a multi-tenanted managed service. What parts of the managed service are exposed to the internet? We're very careful about not exposing things. Do we ever share an API which is used by a human usable front end versus like an agentic system? What data can pass from the client to the managed? What data can pass from the managed to the client? There are different deployment mechanisms, right? We do continuous delivery virtually every commit for the managed service, but the client side that means that we need to do something on our client, and maybe that might get updated once a week because it's deployed to their systems. So that's the type of thinking I definitely want to keep into the engineers that I work with. So one thing we do now is when we're planning whatever work we're going to do in the next week, is if we think there's a system level decision, that always comes as a completely separate pull request in something called an architectural decision record. If you've not come across those, Google them. It's about documenting your technical decisions along with your code so that someone can quickly learn why we made the decisions so we don't keep on discussing them again. And we've always used ADRs, or at least for a very long time. And when we first adopted agentic development, the agents loved writing ADRs. They were very good at seeing that we had ADRs, so they wrote more ADRs. And our ADRs got longer and more verbose, and not a single human understood them, which completely defeated the point of having them. So what we did is we said, from now on, we're going to start with the ADR. Me as a human, I'm going to spend a lot of time reviewing it. I want diagrams. I want them to be visual so I can understand them. And then humans reviewing them can really put a lot of effort into reviewing those architectural decision records. And once you've got those, agents are really, really good at reviewing implementations against well-structured architectural decision records. Not only when you eventually land the implementation, but all of the follow-up requests then. Because one thing I don't think humans are good at is keeping all of those ADRs in your head, and then subsequent pull requests which subtly perhaps change your system architecture. You might not realize that something's happening, like a new API is exposed. But what we actually do is have the ADRs constantly reviewed against all of the pull requests that come in. So that's kind of my first tip about not delegating systems thinking to agents. The next thing I wanted to dig a bit deeper into is have a real think about the dependency you want to put on the producer of your digital product. So if we go back to this diagram, and we've accepted that maybe we don't understand how agentic workflows actually produce code, if we were to break it down a bit more, so I'm breaking down the producer box into three things. We've heard the first one. I've called it interface, but in most places we'll call it harness, like in the keynote. So there's an interface for how you do that, right? That could be Claude Code, it could be open code, it could be Codex, it could be some agentic automatic workflow based off your GitHub issues. Then you've got the thing which is hosting your model, right? So that could be directly, it could be the Anthropic API, but you could be hosting your own. You could be using a third party, which routes between them. And then you've got your model. So really, your black box is made up of three things that you don't understand. It's Claude Code, it's an API, which perhaps at 3:30 on an afternoon stops working. Anyone experience that? Does anyone feel the most productive once the Americans wake up and make the Anthropic APIs go down? And then you've got the model, which obviously you don't understand. I'm not saying you obviously understand. If anyone wants to explain how Opus works to me, I'm very happy to hear it. So we can choose not to be quite so coupled to that workflow, right? We can use a harness, which is open source. What's the benefit of that? When Anthropic goes down, I just switch to OpenAPI with a single command and I carry on. I obviously get different results, right? Every model gives you different results, but it's good to have the way that you're building your digital product be able to flip between providers. You could go as far as to hosting the models themselves. That limits the models you could do. You could use something like Kserve. And then if you want, you could use a model with open weights, or at least an open source way that it's trained. I don't think any of that is that important, apart from being able to switch between providers very quickly. If you've got a production outage, and suddenly at the same time that, say, your favorite AI provider does, and the only way your engineers can debug production is with that model, good luck. I think it's more important that you end up understanding the product that's developed, because they can't take that away from you, I don't think, right? It's produced, it's your intellectual property. It's a whole different ballgame, though, if you build LLM interactions into your product. Then you've got another black box inside your black box. So, vendor lock-in is fine as part of your development process, maybe. We've all done it, cloud providers, all sorts of things. But make it a conscious choice in your organization and understand the consequences of that producer going down at key points for your business. The next thing I wanted to dig on is the changes we've made to the flow of how software development happens, all the way from idea through to working software in production, and actually one step further. So I'm talking from now on about like an existing product with real users, with real data. So we're not talking about like an existing like greenfield, like prompt off you go. And it's got users. So we have product management, we have ideas. Anyone can have ideas in the company about how we evolve the software. We have product ownership, so that's coming up with a concrete plan for turning those ideas into taking what we've got and modifying it and ending up with hopefully a coherent product. We've got people who build it, actually go off and execute it with all the new tools. And often the step which is forgotten about, which is driving adoption and evaluating whether the idea was actually a good idea, right? Because every time we change our product, our digital product, it's an experiment. And there's no point doing experiments if you don't actually look at the result and then learn from it. So all of this should feed back into that process. And that is the amazing thing about agentic development, because some feedback can be actioned right away. And if you have a good path to production for deploying the software, as your users are starting to adopt it, if you're sat with them, perhaps if you're a client, you can actually just change the software right in real time and have it deployed through to your path to production. And one thing that we noticed is the different stages of that path to production had different speed-ups from AI. So this is just our experience, yours might be different. The building is where the order of magnitude has gone up, right? If you give a senior software engineer like the time to just build features, they can build as many features as you want right now. They might not be the right features. If we go to the product management, product ownership, we heavily use AI there too, to do product market research, to analyze user feedback, to build roadmaps, to refine issues. But there's a lot of decisions to be made there. Right? There's a huge number of decisions. It's much more important to decide what we're building, in what order, and that is not something I delegate, so that's why we haven't found we got the same speed up as we did in building. And this one, for a while, has actually got harder, right? Because we're providing too many features to our clients sometimes, great problem to have, isn't it? Which can make adoption harder because we keep dropping new features before the previous ones. So I think look for friction in your processes caused by different levels of acceleration. And you work out what your flow of software development is. And one kind of tip which we've recently executed on is to have software engineers be directly responsible for adoption of the features they build. Do not let them just go and build the next feature, because you end up with lots of unadopted features, which is essentially useless. And if you don't do something like this, or you don't speed up product management in the same way as you do building, you have to expect software engineers to build features that you do not need, because it's fun, right? AI-assisted development is fun, and the friction for an idea turning into working software has gone down, so we often end up with features that we don't want. So the way I think about it right now and how the software engineers work in my team is that we've merged together the friction of getting adoption with the building, right? So engineers aren't allowed to go and build the next feature until they've done everything they possibly could to get that feature adopted. And I come from a software development background that became a platform engineer, and I really believe in the cultural side of DevOps. And you build it, you run it was something which I've said for many, many years, and I really believe in. But for now, it's like you build it, you run it, and you have to drive the adoption of that feature. Otherwise, you just end up with too many features, unused features in production. I'm now going to dive a little bit deeper into how the role of our software engineers have changed over the last year. And I'm going to break down what they do into roughly three steps. So we're now just in the build box of the previous diagram. So technical planning is the first part of actually building a feature. Architectural decisions, testing strategy, how to integrate with third-party and dependencies. That's where you're using a lot of your brain. A brain as a software engineer. It's absolutely the thing we put into ADRs that I talked about at the start. Then we come to execute on said plan, and obviously that's the bit that's got extremely good with AI, so code, what used to be nice and relaxing. And then we refine. And for me, the refinement is where the magic is at with AI, because we can quickly iterate on our ideas based on user feedback. If people don't use things like superpowers, I would highly recommend it. That's the one that we use. There's obviously spec-driven frameworks that people use. But this kind of matches the brainstorming would be the technical planning. But don't delegate to it. It's going to ask you lots of questions. It's going to make you feel very informed. But it's up to you to come up with the right technical design. And then obviously the writing and executing plans if you haven't broken your software development flow into that. So one of the key changes in how an engineer spends their time is previously I'd have spent a short amount of time doing technical planning, quite a long time relaxing with my cup of coffee, coding, I found that quite therapeutic, and then doing that validate and deploy. And most people feel like a superhero initially, right? Superpowers is a very apt name because I can go so fast with AI. At the same time, does anyone find AI frustratingly slow? Right, I've come up with the design, I've told you how to implement it. Why does it take 30 minutes for you to go and do that 4,000 line change? Come on, AI. So what do we actually do? Right? Everyone's probably gone and done this. That's my flow. I've compressed the coding. So what do we do once we've done the first technical planning? Any guesses? Yeah, we start another one. Good answer. And then we start another one, right? And we all end up very, very tired. So parallelism is definitely necessary. In our engineering handbook, we actually almost mandate it. Everyone in my company is assigned multiple tasks at the same time. But we have to be careful about it. Because what we found happened is, if let's say people had 3 complex tasks to do, like 3 features which required your brain to think about the system architecture, the first one would be fantastic. The second one would be not so good. By the time you got to the third one, it would be a load of rubbish. So even though we hadn't delegated our systems thinking to AI, we've already used up our brain, so it's going to come out a bit rubbish. So, one of our kind of guiding principles is to work in parallel, absolutely, but only work on one complex task at a time. And we starting to label issues and things to say, yeah, you can pick up these to go while the agents are doing something else. Everything I've said so far is about the individual, right? But I'd say the hardest part of this, our new way of building software, is how to get a team to work together to solve problems with AI. And I do think you need a team, right? As in, I want a team of people that can operate and evolve and maintain my digital product. I don't want one hero. I don't want some AI system that's not accountable. I want them to use AI as much as possible to build it. But people are should be accountable and have the real agency. So I'm sure a lot of people have heard of Amazon's 2-pizza team. Keep team sizes down to 6 to 8. Absolutely ludicrous idea as far as I was concerned, because obviously if you've got 8 people, you need 8 pizzas to feed them. It's definitely not 2. I think American pizzas are bigger than ours. Anyway, let's assume that you can feed a team with 2 pizzas, right? If you don't think about it, what's going to happen is this, right? Everyone's going to be addicted to their new game, which is AI-assisted software development. They're going to prompt. And what's going to happen? Lots of pull requests, right? 48 pull requests. And then someone is going to tell you that the most common complaint in AI-assisted software development is, what is it? Reviews are the bottleneck. This is crazy. I think this is crazy, right? Because we're complaining that we can build so much valuable software that we don't have the time to look at it. And we've spent a couple of decades inventing practices to build a shared understanding of a system and maintain it, right? We're talking about XP, pairing, mobbing, boomerangs. We did all this stuff with the goal of not having knowledge silos, right? I already think this helps, right? Because if you put the friction of adoption directly to the engineers, they don't build quite as much stuff in parallel, which is a good thing, because what you want is the outcome of the use of the software, not just features in production. And this is I've gone through most of the engineers I work with, and yet you cannot get your self-worth from the features you prompt. This is not a new problem with AI. We've always struggled with people want to tippy-tap the code, get the commit on GitHub, rather than review other people's stuff. But it's massively accelerated by AI as a bigger problem. Anyway, so what have we done about it? So rather than having our normal team sizes of 6 to 8 people, we've made them much, much smaller. So they're now 2, at most 4. And we give them a mission, and their mission is based on adopted software by particular customers. And you're not allowed to start the next feature unless you've done everything in your power. So if we're at a stand-up and you're telling me how great the next feature you're building is, but you haven't spoken to that customer about getting them to use the previous feature, that's not something we do anymore. Which then means that small substream needs to, do the reviewing, fix the bugs, gathering the user feedback. The most important part of this, though, is if we break that team of 6 to 8 people into substreams of 2 to 4, is you get 3 pizzas. Because obviously you can't have 2 different substreams share pizzas. The problem this produces, which is the same problem that we had when we broke up bigger teams into teams of 6 to 8, is they can go off in different directions. They've got a mission, they've got focus, that's fantastic. So you really need to think about how you're going to do product ownership across these different streams. Let them work in isolation, let them just review their own stuff, but make sure that key architectural decisions are still reviewed by the right people, and make sure there's at least 1 or 2 people who are working across the streams and understand how everything's going to work together. So a question I keep asking myself through all of this transformation is, has AI changed good engineering practices? And, this is a graph I've completely made up with no real data, but we start off with high velocity, and then we get slower, and then we fix some stuff, and then we get slower, and then we fix some stuff, and then we get slower, and then maybe we end up somewhere, below what we started at, right? So we start off conquering the world, and then eventually we end up at some steady pace for our digital products. So what causes this? Well, there's 2 answers. There's technical debt, that's the obvious one, and the other one is success. Obviously, success is not necessarily a bad thing. When I say technical debt, it's things like longer testing cycles, more dependencies, harder to make code changes. And obviously, agents will have the same problems that humans have for modifying a code base in a safe way. Success is going to be things like more customers, more deployments, larger data sets. So there's certain engineering practices which I think are even more important. I've got more than I can cover in this talk, but I'm just going to cover a couple, probably one that I've got time for. 1 minute, there you go, one. Now, the first is system architecture really matters. I already talked about this, but why do we break things up into loosely coupled services? Maybe, very important word, loosely coupled. Otherwise, you've just got a distributed mess. Right, it's for fast feedback cycles. If we're going to build more features, we're going to end up with larger systems. I'm talking about complex systems rather than just like say, trivial web apps. It is imperative that we keep the feedback of each of those components very short. It's 15 minutes for me is an absolute maximum for running a full suite of tests, which gives me a high level of confidence that that thing works. The other thing is, if we're going to modify software more quickly, blast radius really matters. What is the worst thing that can go wrong when one instance of a pipeline path to production happens? So an only really way to do that is to design your systems so that if one of these components goes down, most of your product functionality still works. And I was going to go through an example of the types of tests we use, but I'm not going to have time, but feel talk to me after if you want to. So I'm going to end on time with a few final thoughts, which is define your principles for using AI. And by that, I mean the stuff at the start. Decide what you want humans to understand versus agents. Decide like what dependency or vendor lock-in you're happy with. Identify your real bottleneck all the way from idea to adoption. Do not get sucked in by vanity metrics that measure one little bit in the middle, like token usage or commits or PRs merged. It has to be adoption. Features in production is what I used to use before AI. That's not good enough anymore. Those features actually have to be used, and you have to expose those to your engineers, or certainly that's what we're trying. Define your definition of good in a very concrete way, and then have AI be held accountable to it. I'm turning this talk into a few articles for our website. If you want us to send you them, just there's a QR code there because we love QR codes these days. They made a real comeback. And thank you very much for taking the time to listen.